Hey everyone, it's Dr. Garner here. I want to continue our discussion of significant figures by looking at how many significant figures to keep whenever you're doing mathematical operations. So in the last video we saw how to count the number of significant figures that are present in a measured value. And we saw that this was a way of figuring out how precise that measured value is. And whenever we do mathematical operations like multiplication, division, addition, or subtraction, we need to consider how many significant figures to keep in our answer to that operation. All right, so there's a couple sets of rules here. So the first set of rules that I'm going to introduce covers the operations of multiplication and division. So whenever you are multiplying and dividing, the number of sig figs that you should keep in your answer is determined by whichever value involved in the calculation had the fewest number of sig figs. And whichever value had the fewest sig figs, that's how many sig figs you should keep in your answer. Let's take a look at an example of this in practice. So here we're given an example where we have 1.045 times 12.1. Of course, if I work out the math here, I'm going to get 12.6445. But what I need to consider is how many sig figs I should round to here, so where I should round this answer. So I need to figure out, based on the values involved in the calculation, how many sig figs to keep in my answer. So again, it depends on how many sig figs are contained within each value involved in the operation. So I need to look at each value here and assess how many sig figs there are. In this first value, I know that the 1, the 4, and the 5 are significant because they're non-zero digits. So those three digits are all significant. The 0 that comes between them is also significant because any 0 that comes between two significant digits is itself also significant. So this first value here, it contains 4 significant figures. The other value involved in the calculation, 12.1, it has 3 non-zero digits, so all of these digits that we see here are significant digits, all 3 of them. All right, so the number of sig figs that we need to keep in our answer is going to be determined by whichever of these values had fewer sig figs. And it looks like 12.1 with its 3 significant figures is what's going to determine where we're going to round our answer. So we're going to also round our answer to 3 sig figs. So if I round this off to 3 significant digits, that's going to be keeping the 1, the 2, and the 6. And dropping the 4 and 5 at the end here. So I'm just going to round this off to those first 3 digits, which is going to give me 12.6. So whenever you do multiplication and division, you need to assess each value involved in the operation and see how many sig figs each value had. Whichever value had fewer sig figs, that's going to determine where you're going to round your answer. All right, so things are a little different with addition and subtraction. With addition and subtraction, it doesn't matter how many sig figs are in the values that are involved in the operation. Instead, it matters where they are, so what decimal place they're in. So with addition and subtraction, you're going to round your answer to whichever decimal place the least precise value involved in the calculation had its last sig fig in. All right, so let's take a look at this in practice. So here we have an example of 12.3 plus 640. Of course, if I add these two values together, I get 652.3. So what I need to do now is I need to consider where I need to round this in order to have the appropriate number of significant figures. All right, so if I look at 12.3 and 640, again, I don't care how many sig figs they have. Instead, I care where their last sig fig is. So in other words, which decimal place it's in. So in 12.3, its last significant digit is the 3 here, and that's in the 10th place. In 640, its last significant figure is the 4, so its last sig fig is in the tens place. So where I'm going to round my answer is determined by whichever of the values involved in the calculation is less precise. So 640 with its last sig fig in the tens place, that's less precise than the tenths place. So that means I'm going to round my answer to the nearest 10. So I'm going to round 652.3 off to the nearest 10, which is going to give me 650. So don't conflate these two sets of rules. With multiplication and division, it depends on how many sig figs each value in the operation possesses, and that's going to determine how many sig figs you keep in your answer. With addition and subtraction, it's a completely different set of rules. It doesn't matter how many sig figs there are, it matters where the last one is in each digit. Whichever value has its last sig fig in the least precise position is going to determine where you need to round your answer to that operation. All right, so let's take a look at an example problem. Remember, the best way to use these example problems is to pause the video and take a moment to work this problem out on your own. Practicing these problems is essential to doing well in the course, so I strongly encourage you to pause the video and try this out on your own before continuing through to see the solution. Alright, so let's take a look at this together. In this problem, we're being given a mathematical operation, and they're giving us the answer that comes out of that operation, and they're asking us to round it to the correct number of significant figures. And of course, we have a couple of steps here. We have, on top of this fraction here, 180 plus 53 inside of parentheses, and then we have 63.1 on bottom that we're dividing by. So of course, we want to start with the step inside the parentheses first. So we have 180 plus 53. So, of course, if we work out the math here, we get 233 when we add these two values together. But if I want to know where to round this answer that I got, I need to consider where each sig fig was in the values that I added together. So remember that for addition and subtraction, it's the position of the last sig fig that matters. So in 180, its last significant figure is in the tens place, the 8. So the 8 is in the tens place. In 53, its last sig fig is the 3, and that's in the ones place. So ones is more precise than tens, so I'm going to round my answer to that less precise position, to the nearest 10. So 230, I'm going to round that to the nearest 10, which is going to give me, 233. If I round that to the nearest 10, it's going to give me 230. All right, so now I want to continue by doing the division operation. So I want to take my value that I got from this operation on top now and divide it by 63.1. So that's going to be 230 divided by 63.1. I want to go ahead and point out here, when you actually do the math, when you type this into your calculator, you're going to want to keep the number that you didn't round. So instead of using 230 here, I want to keep 233 when I actually do my math, but then I'll round once at the end of the problem. So that's usually a good strategy. Don't round too early. So keep more sig figs than you need until the very end, and wait to round until the very end of the problem. So that's what I'm doing here. So even though I wrote down 230, when I work out the math to get the value that's given in the problem, I used 233 to get that value that I'm showing here. All right, so for now though, I'm just going to write in 230 so that we can see how many sig figs are in that value a little bit more easily. All right, so for this division operation, remember it's the total number of significant digits that determines how many sig figs you keep in your answer. So I need to look at both values involved in the operation and assess how many sig figs they have. So 230, only the first two digits are significant. The 0, since it is not to the right of a decimal, is not going to be significant. So 230 possesses 2 sig figs. If I look at 63.1, all 3 digits are non-zero, so they're all significant. So 63.1 has 3 significant digits. All right, so with multiplication and division, it's whichever value has the fewest sig figs that's going to determine how many sig figs you keep in your answer. So since 230 only possessed 2 significant digits, that means that I'm only going to keep 2 significant digits in my answer. So I'm going to round 3.692552 off to 2 sig figs. So I just need to keep those first 2 sig figs there. So since the next digit's a 9, that's going to cause the 6 to round up, so it's going to give me 3.7 when I round off to 2 significant digits. So it's going to give me choice B. All right, we'll stop there for this video. I'll see you guys in the next section.